Alright, welcome back. We are going to go through ATAR Notes question number 7 for Module 5, Advanced Mechanics. If we go through this question, let's just quickly read through everything. We have 100 grams of a ball, this one here, swing around the top of a stick in a circle radius of 0.65 meters. A student observes that the ball is spinning around in the circle about 45 times per minute. Okay, so the very first question we want to work out is angular velocity. Angular velocity is given by this formula here, omega. Now, if you look at your data sheet, omega is given by change in angular displacement over time. I'm going to change this up a little bit. So if we are able to do one whole rotation, and we're going to do this in terms of angular displacement, the angular displacement we have here would be 2 pi, because that's the entire distance it takes to rotate around a circle. The next thing I need to know is time. And to be very precise, I want to know the period. So how long does it take to do one rotation? And that's where we use this value here. So if I want to find the rotation, I'm going to look at the amount of seconds we use. So in 60 seconds, I have 45 rotations. So I have 45 rotations in total. Okay, and that would give me roughly 1.33 seconds. Okay, in this case, obviously you can just leave it in 3 sig figs, that'll be fine. Or if you like, you round off to the smallest number. The only thing when it comes to rounding up the smallest number, if there are questions where they only give you 1 sig fig, so let's say it's like 1 gram instead of 100 grams, then there's really no point in rounding it off to 1 sig fig there. Obviously, if it's a really big number, try and round it off to a smaller one, but if it's a really small one, then just stick with 3 for now. And so if we have, and for those who are genuinely curious, it's just 3.33 repeater, so that's the whole value there. Okay. So I now have some useful data. I'm going to actually write out how to perform the calculations. So it's going to be omega 2 pi over capital T. Okay, so we already talked about where all those values came from. And then 1.33 repeater. So 2 pi. And I'll find that the angular velocity is 4.728898 radians per second. If I round it off to the lowest sig fig of the question that I used, that would be 2 rads per second. But you know, if you want to do 3 sig figs in the New South Wales syllabus, at the very least, they're not that concerned. They don't specify how many sig figs you use, so you can use the standard one, which is 2 here, or you could just go to 3. All right, the next one is to draw a vector diagram showing the forces acting on the ball. So I'm going to draw it out. I'm going to have my little stick here, and then I have the ball. So that's what I have. If I try and add in the relevant forces, firstly, I'll always have gravitational force going directly down. And then I'll have my tension force, okay, going across like that. Now we do know that the tension force, at least the vertical component of the tension force balances out the gravitational weight force. And what we see is a net force going in like that, which is also our centripetal force there. So that's all you need for that one. All right. Next one we come across, it says calculate the magnitude of the centripetal force to keep the ball moving in a uniform circular motion. So the formula we're using is F centripetal m v squared over r. So, let's go through some of our bits here. So mass, 100 grams, so 0.1 kilograms. The velocity that we haven't actually worked that one out, I don't think. No, we haven't worked that out. So we just need to work that out from there. And our radius is 0.65 meters. So radius is 0.65 meters. We don't know what V is yet, so let's just find V quickly. So V is 2 pi r over t. We know that 2 pi is that constant, radius is 0.65 over time, repeater, and the subsequent value I get for V is 3.06305287. Again, you can just round this off to 3 significant figures to do your calculations, but at universities and stuff, you don't round off until the very end. So I'll just keep with that style. So 0.1 times our velocity, which is quite messy to write, over our radius. Which gives us a centripetal force rounded off to 1.4 newtons. If I'm just rounding off to 2 sig figs. If it's 3 sig figs, it would have been 1.44. All right, the last one we're going to do is the tension force. So if we redraw the pendulum, or if we just look at the pendulum drawing we had earlier, that's what we have. We have the gravitational weight force like so, and then we have the tension force like that. If we kind of draw the triangle out and kind of connect it together, here we have is the gravitational weight force. So in this kind of bolded line here, and we actually have this line as well. What is this line? That is the net force, or the centripetal force that we just found. Okay, so imagining that is a right angle triangle, we can just solve this as a solve this as a right angle triangle using Pythagoras theorem. So let's draw it out. We have our triangle. Okay, we have FC here and we have FG. So we want to find tension force. So tension force equals 2 Fg squared plus Fc squared. So if I put those numbers together, Fg is mass times acceleration due to gravity. So 0.1 times 9.8 plus our centripetal force. In this case, we'll just use the previous number we worked on, which is rounded off. So let's just say around about 4.43. So I'll just use the whole number, 3429644 squared and put that into my calculator. Don't forget the square root there. And we get a tension force of 1.744674508 newtons, rounded off to 2 sig figs, 1.8 newtons. Or you can do it as 3. So if it was 3 sig figs, it would be 1.74 newtons. Like I said, in the HSC, the best way to go is 3 significant figures. If you can't, as it's not told to you really explicitly, so 3 sig figs is the simplest way to go about it. Otherwise, if you go with conventional methods, you do go with the smallest value given to you in the question. But in some of the questions they give in the HSC, they don't give it to you in many. They sometimes give it to you in 1 sig fig only, and so that's not very helpful for your final answer. But anyways, if you have any questions, just let me know. As we do always, that's how you do the question.